So this is the second part of our angle relationships lesson. In this case though, we're going to talk about angles that are formed by parallel lines. And maybe you've driven on a highway or a parkway of some sort and you've seen an intersection of two major roads. Like I look at this, when I see this, I think about the intersection of the Taconic State Parkway going north and Interstate 84, about 20 minutes north of where we are. And I see the two lines going across, and it's like the roads are parallel. It seems like this highway and this highway are parallel to each other. And then this other road kind of crosses it at some kind of an angle. So we're going to talk about that in a minute. And again, we need a little bit of vocabulary here. So the first thing I want to introduce is this line over here called a transversal. So a transversal is a line that crosses two other lines. Let's see if I can type that in. A line that crosses two other lines. It doesn't have to cross really two. It could cross a lot more than that. Let's see if we can make that a little bit smaller for you so it doesn't take up the whole screen. There we go. We'll throw that up there with transversal. So our transversal is intersecting these lines and makes angles 1, 2, 3, and 4. And then it keeps going. It crosses the other one and it's angles 5, 6, 7, and 8. And we have some relationships between these angles. And that's what we want to investigate today. But first, let's define what the corresponding angles are. Corresponding angles are angles that are on the same side of the transversal, but one of them is in between the parallel lines and one of them is outside the parallel lines. So in an example, and I'm not going to use my angle symbol, but I'm going to use like angles 1 and 5 are a pair of corresponding angles because angle 1 and 5 are on the same side of the transversal. 1 is on the outside of the parallel lines and 5 is on the inside of the parallel lines. So angles 1 and 5. Can you name some other pairs? How about 2 and 6? How about angles 3 and 7? And how about angles 4 and 8? And again, we'll make that a little bit smaller. Alrighty, those angles are our corresponding angles. The next one we want to talk about are the alternate interior angles. The alternate interiors, and if you think about the wording of it, alternate meaning alternate sides of the transversal. Interior meaning inside the parallel lines. So can you name a pair of alternate interior angles? If you said angles 3 and 6, you're correct. And if you also said angles 4 and 5, you're correct as well. You know, I should probably change my settings so it writes that small all the time, right? That makes sense. And the last pair we want to talk about are the alternate exterior angles. And if you know alternate interior, you probably know alternate exterior angles. So a pair of alternate exterior angles are angles 1 and 8. Those are on alternate sides of the transversal and on the exterior, the outside the parallel lines. And its other pair are 2 and 7. So those are our alternate exterior angles. Now remember this symbol, this geometry or sketch pad. That's going to show some relationships between them. So let's take a look for a minute. So the first one we're going to bring up is the corresponding angles. So I'm going to click the corresponding angles button and I want you to take a look at what it might show you. This green angle is a corresponding angle and it slides down to the other one as well. So what do you think is true about the measures of the corresponding angles? Maybe you want to watch it one more time. Ooh, oh, unbelievable. Who knew geometry could be so much fun? So let's also take a look at the alternate interior angles. So again, I'll click a button, an alternate interior angle is going to appear in blue and it's going to move. It goes to its other alternate interior angle. Oh, it rotates. That's so cool. So what do you notice about the measures of alternate interior angles? Wait, don't say it yet. Don't say it yet. Let's talk about the alternate exterior angles. Here comes a red one, and it's going to go to its other alternate exterior angle location. What do you think is true about the measures of those angles? Holy cow, I think I got it. Well, let's take a look. So when you see the screen, you go like, oh, I got to write so much stuff down. No, you don't. Hold on. So let's figure out what we said first. If two parallel lines are cut by a transversal, what did you notice about the corresponding angles? Did you notice that they were congruent? Yeah. And if you go down to the next one, don't write anything down yet. If you go down to the next one about the alternate interior angle conjecture, did you notice that if the parallel lines were cut by a transversal, that its alternate interior angles were also congruent? Holy cow, this is great. And the alternate exterior angles, if those parallel lines are cut by transversal, angles 1 and 8 are my alternate exteriors, did you notice that they were congruent as well? Wow. So we kind of abbreviate some of these at times. The CA conjecture for corresponding angles. AIA, that's my favorite for alternate interior angles. And the alternate exterior angle conjecture, AEA. Don't write, we're going to combine them all together. So if two parallel lines are cut by a transversal, what we know is that the corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. All that is true. We'll draw an arrow up to that one. Hey, we're going to draw an arrow. Let's do that again. We're going to draw an arrow up to that one. We're going to draw an arrow up to that one. And we're going to draw an arrow up to that one. And we're going to get rid of that segment. Boom. That's what you want to write down. That's the conjecture we want, the parallel lines conjecture. That says if parallel lines are cut by a transversal, all of those angles that we named, the corresponding angles, the alternate interior angles, and the alternate exterior angles, they are all congruent. Cool, let's keep going. Let's play a little bit. Let's do some angle chasers. So what I mean by angle chasers is when I give you a diagram and I say determine the measure of an angle. So in this picture, notice that these two symbols here, let's see, can I trace around it? Yeah, let's trace around it. Those two symbols there mean that these two segments are parallel to each other and they're cut by a transversal. Get rid of those things. The angle marked is 108 degrees and you're asked to find angle number 1. Give it a shot. So a lot of different ways to progress here. What you might want to recognize, one way to do it, is to think that I have a pair of alternate interior angles. So this angle here is 108 degrees. And if that angle is 108, remember the linear pair conjecture that says a linear pair of angles is supplementary. So that's going to make angle 1 be 72 degrees. So the measure of angle 1 equals 72 degrees. How cool is that? Now, I'm going to think a little bit about this because 72, 108, those are cool numbers. You notice anything about those numbers? Let's go back to Geometry Sketchpad for a sec. Because we hit corresponding angles, alternate interior and alternate exterior. But if you look at those two angles there, the 108 and the 72, they're not alternate interior, they're not alternate, they're not any of those angles. Instead, they are what we call same side interior angles. Those are angles that are on the same side of the transversal and both on the inside. So we got a button, let's press it. Notice those red and blue angles? Where are they going? Oh my goodness. What did they do? Worth watching one more time, friends. Tell me something about the same side interior angles. If you want to add that as a conjecture, that interior angles on the same side of the transversal are supplementary. Sounds good. Interior angles on the same side of the transversal are supplementary. Yay, we like that. So friends, that concludes our lesson today on angles formed by parallel lines. I hope you had some fun.